In today's notes, we're going to look at writing quadratic equations in standard form. But before we do that, we're going to go back and remind ourselves how we solve an equation to find the zeros. Because we're going to be given the zeros and work backwards to write the equation. Okay? So in the given equation, to find our zeros, we start by factoring. So to get x squared, we x times x. 2 is prime, so that's pretty easy. It's going to be 2 times 1. And since the signs, again, it multiplies to a positive product, but combines to a negative 1, it's going to be negative 2 times negative 1. That gives us the positive 2, but the negative 2 combined with the negative 1 is the negative 3 in the middle. Now since x minus 2 times x minus 1 equals 0, anytime you have two terms that multiply to give you the 0, either one or both equals 0. So now we take and set each factor equal to 0 and solve. So we end up with x equal to 2 when we add the 2 over, and when you add the 1 over, you end up with x equals 1. Okay, so our two roots are 2 and 1. And remember, the roots, so 1, 2, the roots are where the quadratic intersects the x-axis. So it's a positive x squared, so it's going to be right side up. And again, I'm just doing a sketch. Here's x equals 1, and here's x equals 2. So they can either give you the roots algebraically or with the graph, and then we're going to work backwards and write the equation. Okay? So sometimes we are given the zeros or roots of a quadratic equation, and we must write the equations for them. And here are the steps to do that. The directions say write a quadratic equation in standard form whose roots are 3 and 6. Well, the first thing we do is we write them in terms of x. Okay? So it's going to be x equals 3 and x equals 6. And from there, okay, you can work your way from this step to this step, but I'm going to suggest, okay, and that's the way I'm going to write it, and in my homework keys, I'm going to go right from here to this step there. So if x equals 2, the factor must have been x minus 2. It's the opposite of a positive 2. If the root was x equals 1, the factor must have been, excuse me, x minus 1. So step number 2, set up the two parentheses equal to 0 with x in your first position. So this is the next step we're going to do. And since the root was 3, this must have been x minus 3. If this root is 6, it must have been x minus 6, as it's the opposite sign. Change the roots to be the opposites and put them in the second position. So really these two go with that. So this line could have been removed as they go together. And then the last step, use the distributive property to multiply the two binomials. So we've got x times x, x squared, x times negative 6, negative 6x, negative 3 times x, negative 3 times x, and negative 3 times negative 6, positive 18. Combining the two middle terms, we've got x squared minus 9x plus 18. And we write it set equal to 0. Okay, because those roots, going back to the picture, are where the parabola intersects the x-axis, and that's where our y value equals 0. Examples at the bottom, number 1 and number 2. Now this is already in the form x equals, the one on the right, when it's a graph, that's actually write it out in terms of x first. So this is negative 1, negative 2, so we have x equals negative 2, and 1, 2, 3, we've got x equals 3. From there, okay, we set up our two parentheses, equals 0. If x equals 3, the factor must have been x minus 3, as its opposite. If x equals 4, the factor must have been x plus 4. Okay, so let's do the little smile, big smile. to get the middle term. So negative 3 times x is negative 3x. X times a positive 4 is a positive 4x. So that middle term is a positive x. The first term is going to be the x times x. So it's going to be x squared, because negative 3 plus 4 is 1. And then negative 3 times a positive 4 is a negative 12. We'll do the same thing over here. So if the root is x equals 2, or negative 2, the factor is going to be the opposite and be positive. If this is x equals positive 3, the factor is going to be x minus 3. Okay? When we actually pull it from the graph, okay, and we're not told it has roots, okay, the picture is actually set equal to y. So if you want to make a note, when given a graph, ax squared plus the bx plus c is equal to y. Only when you're given the roots, okay, is it going to be equal to 0, okay? On the back, so we're given a graph again, so it's going to be the term in the form y equals. So we have this one, our two roots. This one here is x equals negative 1. This one is x equals negative 4. So the factors are opposite, x plus 4, x plus 1. Go ahead and distribute. Actually, let's do a little small, big small again. We know x times x is x squared. 4 times 1 is 4. But that middle term is going to be 4x plus 1x, which is 5x. Now, because the parabola is upside down, this is where it highlights on that first part of your notes. I believe I skipped right over. If the quadratic equation opens downward, we multiply our final answer by negative 1 to turn it upside down. So multiply this by negative 1 to make it a negative x squared, which opens down. And we get negative x squared minus 5x, and that positive 4 changes to a negative 4. And it's equal to y because it's a graph. Last one, number 4, write the equation of a quadratic with the given roots. So given roots means it's going to be equal to 0. It's downward opening and the roots are given. So if it was x equals negative 7, the factor is x plus 7. X equals negative 2, the factor is x plus 2. So x times x is x squared. 7 times 2 is negative 14. And that middle term, 7x plus 2x, is 9x. Because it's opening downward, we're going to multiply that by negative 1. So distributing the negative all the way through, we end up with negative x squared minus 9x. Oh, I had a mistake here. Positive 7 times positive 2 is a positive 14. Now multiplying by negative 1 will be negative 14. And it's equal to 0 because we were given the roots and not the graph.